Right, we are required to prove that for Z and W, which are elements of the set of complex numbers. Number one, the modulus of Z is less or equal to the modulus of Z minus W plus W. Two, the modulus of Z minus the modulus of W is less or equal to the modulus of Z plus W. Three, the modulus of Z plus W is less or equal to the modulus of Z plus the modulus of W. Four, the modulus of Z plus W is greater or equal to the modulus of Z minus the modulus of W. All right, property number three is actually called the triangle inequality. We proceed to solve and to write down the solutions to all the four inequalities, and we proceed. Right, so required to prove that the modulus of Z is less or equal to the modulus of Z minus W plus W. So the modulus of Z is actually equal to the modulus of Z minus W plus W, like so. Right, using the triangular inequality, this is the modulus of Z minus the modulus of W plus W. And this therefore means that it implies that the modulus of Z is the modulus of Z minus W plus W. And this is what we had to prove here. And we are done with this proof. Is required. Is required. Okay. Right, in number two, we are supposed to prove that the modulus of Z minus the modulus of W is less equal to the modulus of Z plus W. So we proceed to focus on inequality number two. Right, required. Required to prove that the modulus of Z minus the modulus of W is less or equal to the modulus of Z plus W. Okay, how do we prove this? Right, we start by considering here the modulus of Z. And we understand that the modulus of Z is Z plus W plus the negative of W. And this is exactly the modulus of Z plus W plus the modulus of W is the modulus of Z plus W plus W. This is the modulus of Z, which is less or equal to the modulus of Z plus W plus the modulus of W. In this is the modulus of Z, can transpose the modulus of W, giving us the modulus of Z minus the modulus of W less than or equal to the modulus of Z plus W, like so. And obviously this here in the second step is by using what you call the triangle inequality. Triangle inequality. Okay. Right. So we have exactly that part there in the as part of the proof. And we are done now. We have achieved what is required, and we're required to show that the modulus of z minus the modulus of w is actually less than or equal to the modulus of z plus w. Now, 3. Right, so in 3, we are required to prove that. The modulus of z plus w is actually less than or equal to the modulus of z plus that of w, like so. Right, let me clean this up. How do we prove this? Like we indicated, that this is called the triangle inequality. The triangle inequality. How do we prove this? We prove it as follows. We start by looking at the left, like so, and we square it. And this becomes what? It becomes the summation of z plus w and z plus w complex conjugate. And this is z plus w into the modular into the complex conjugate of z plus the complex conjugate of w. And then what is this? This is exactly by multiplication, by distribution is z times z bar plus z times w bar, the complex conjugate of w, plus w times z bar plus w times the complex conjugate of w. Right, and we proceed to solve this. And what is the meaning of all this here? So this actually here essentially means that we have with us z times z bar plus z times w bar plus z w bar with the bar plus w times w bar. And then what is this? Right. This can be seen as z times z bar plus. Okay, if you add a complex number with its complex conjugate, we get twice the real part of z times w bar plus w times w bar, like so. And what is all this? Right, at this point, we're able to see that this actually is exactly the same as z times z bar plus 2 times the modulus of z, the modulus of w times w bar. Okay, I'm going to proceed right now to solve this. So what have we achieved so far? We have been able to achieve that the modulus of z plus w squared. Right. So the modulus of z plus w squared is less or equal to z bar or z times z bar. Okay, let's equal to z times z bar plus 2 into the modulus of z, the modulus of w plus w times w bar. Right. Okay, let's see this one here. This one, we square this. We have this and we square this. And here, this is exactly less or equal to the modulus of z plus the modulus of w all squared. Right, and this means the modulus of z plus w is less or equal to the modulus of z plus the modulus of w, like so. Okay, so what have we achieved so far? Hence, the modulus of z plus w is less or equal to the modulus of z plus the modulus of w, and this obviously becomes what we call the triangle inequality. The triangle inequality, like so. The triangle inequality. Right, so we continue right now to prove the fourth one. Okay, so this one here is sometimes called the reverse form of the triangle inequality, or the backward form of the triangle inequality. So let's proceed to prove the fourth relation. So we're supposed to prove this, number 4. 4. Required to prove that we're required to prove that the modulus of z plus w is greater or equal to the modulus of z minus the modulus of w. Right. Now, we note that the modulus of z is the modulus of z plus w plus the negative of that, less or equal to the modulus of z plus w plus the negative of this, the modulus of z plus w plus the modulus of w. And so this means that if you have the modulus of z plus w, it is greater or equal to the modulus of z minus the modulus of w. Moreover, we can consider also the modulus of w, because the modulus of w is modulus of w plus z plus the negative. And this is less or equal to W plus Z plus the modulus of the negative of W. And this is the modulus of W plus Z plus the modulus of Z. Upon further examination, this means the modulus of Z plus W exactly from this part of Z plus W is actually greater or equal to the modulus of W minus the modulus of Z, like so. Right, so number 4 is being continued. Hence, what have we achieved? Okay, we have achieved two significant parts of the argument. So now the modulus of Z plus W here is greater or equal to the modulus of Z minus that of W. So we note that result. Z plus W is greater or equal to the modulus of Z minus the modulus of W. And so the second part, you have the modulus of Z plus W, which is greater or equal to the modulus of W minus the modulus of Z. The modulus of Z plus W is greater or equal to the modulus of W minus the modulus of Z. And this is what we achieve. But look at this very, very carefully. What is all this and what is the implication of this? Right, so there is a biconditional that exists here because this is the same as the modulus of Z plus W is greater or equal to the negative of the modulus of Z minus the modulus of W. Right. And right now, this one here, you can label these as with an asterisk and this one double asterisk. Okay, so now, with that said, what is the consequence of this? Well, the consequence of this is therefore that the modulus of Z plus W is greater or equal to the modulus of Z minus the modulus of W, like so. Okay, and this is the result. This result is called the backward form of the triangle inequality. Right, so we have this, and is called the backward form. Backward form of the triangle. Triangle inequality. It's called the backward form of the triangle inequality. If you don't want to call it the backward form of the triangle inequality, it's also called the reverse form. The reverse form of the triangle inequality. Like so. And we have proven the 4 inequalities that we had to prove. So yeah, thanks everybody for your attention, and goodbye to you.